Welcome to Sir Majesty's World Science Channel once again. Today we'll take a look at a topic in chemistry that try to give students one kind of tough time. The tough time is not that it is too difficult, only that you have not been told the secret. So today's class will just open it in an easy way, because this channel is Easy World, of course, and that is Easy World of Science. So that topic is stoichiometry. That is, it involves calculations relating mass and volume using their mole ratio. So our topic is stoichiometry. So by definition, what is stoichiometry? Stoichiometry is the relative proportions in which elements combine to form a compound, or in which substances react. And to get it in a practical way for calculation, stoichiometry of any reaction is represented by the mole ratios of the reactants and the product. And the mole ratios here, we take it as the coefficients of the reactants and the product in a balanced chemical equation. Let's take a good example of an equation. See reaction of calcium carbonate 4 with HCl to give you calcium chloride plus water plus CO2. First, in stoichiometry, you have to balance the equation. We will not rush this class because it is delicate. If we rush it, we may get confused. First, look at the equation. Chlorine is 2, but it's 1 here. You just put 2 here. And that 2 has done justice to everything. That balances the equation. You can see that oxygen here is 3. This is 2 plus 1. That's 3 still. Then calcium 1, 1. Every other thing is balanced. Then the stoichiometry of this is 1, is represented by the coefficient of this, which is 1. Remember in science, x, the coefficient of x remains 1. So when this is alone, the coefficient is 1. Then the mole ratio here is 2. So 1 is to 2, is to 1, is to 1, is to 1. So first, for you to do well in this topic, you must know how to balance chemical equation. So we have taught you how to represent stoichiometry. So with this, you can now see that 1 mole of calcium carbonate is required to give us calcium carbonate for 1 mole of it. When you react it with 2 moles of HCl, it predicts the combining powers, the combining ratios of elements in the formation of compound, or combining ratios of substances in formation of compound. And what is the advantage of this? This is what makes chemistry be applicable. With this, you can know the amount you want to produce, and now the raw materials needed to load in, because your raw materials should now be your reactants. Your final product should be your product. So even if you are working in industry, in industrial production, you need this equation. Maybe you are producing soap, you can, from the equation, you know the grams of soap you are looking for, then you should know the accurate sodium hydroxide and other bases that you can measure to give you what you want. Now, we cannot do without mole in this stoichiometry, since it works by mole ratio. And just for your information, this will help us to understand mass and what? Volume relationships in a chemical equation. And the determinant is mole. So we will briefly discuss what mole is. So short mole concept first. What is a mole? Mole should be an SI unit. Some don't even know that. Mole is the SI unit for amount, and it is represented by this as an SI unit, and it's an SI unit of amount of substance. Amount of substance. So by definition, 1 mole of any substance, 1 mole of any substance is the amount of that substance that contains elementary entities or formula units, elementary entities or elementary units, as there are carbon atoms in carbon atoms in 12 grams of carbon 12. So the reference point is the number of atoms in 12 grams of carbon 12. Then watch this. From here, elementary entities, please check another one. Elementary entities in 12 grams of carbon 12 is called Avogadro's number by definition. So the number of carbon atoms in 12 grams of carbon 12 is what we call Avogadro's number, Na, and it is numerically equal to 6.02 times 10 raised to the power 23 per mole. So one can now replace this by saying that 1 mole of any substance is the amount of that substance that contains Avogadro's number. You make the definition short. The amount of any substance that contains Avogadro's number, that is 1 mole. Just like when you talk about dozen, you think of 12. This time around, if you talk about mole, you should think of this number. No other number comes into your mind except this number for particle, 6.02 times 10 raised to the power 23 per mole. Now, one should be specific because we have 1 mole of an element, 1 mole of a compound, and so on and so forth. Then one should know that the mass of 1 mole of any substance is called molar mass. The mass of 1 mole of any substance is called molar mass. In the other way around also, you should know that at STP, 1 mole of any gas occupies a volume of 22.4 dm cube. That is at STP. But at RTP, that's at room temperature and pressure, 1 mole of a gas occupies a volume of 24 dm cube. Some exam bodies use 22.4 dm cube, some still use 24 dm cube, but the physical environmental factor are not the same. The other one is RTP, 24 dm cube, STP, 22.4 dm cube. Now, all this thing is hovering around mole, which means mole is our control, our determinant. Please don't miss any step here, because if you do, when we get into the calculation itself, you get lost. Okay, so if they tell you that 1 mole of students attended the seminar, what does it mean? It means that 6.02 times 10 raised to the power 23 students attended. Simple. Now, we will have to have a relationship now. Mole should be the determinant, and it should be 1 mole. Then I told us that 1 mole of any substance, as far as particles are concerned, must contain Avogadro's number, which is 6.02 times 10 raised to the power 23 particles. This time around, when we are talking about particles, stroke atoms. Particles here can be ions, atoms, or molecules. Then the same 1 mole of any substance for gases now. 1 mole of gas at STP will occupy what? Let's take it 1 mole of a gas at standard temperature and pressure will have a volume of 22.4 dm cube. Please, 22.4 dm cube means 22.4 liters. Then the same 1 mole of a gas at RTP, that's room temperature and pressure, occupies a volume of 24 dm cube. Then the same 1 mole of a gas, not gas this time around, 1 mole of any substance. The mass of 1 mole of any substance means the molar mass or the relative atomic mass. Molar mass or relative atomic mass. The same mole in the center. Then 1 mole of an electron during electrolysis. 1 mole of an electron during electrolysis. 1 mole of an electron during electrolysis is discharged by the 96,500 coulombs of electricity. So it depends on the direction you want to follow. Now, with this, there may be other connections. These are the guide. 1 is in the center. Then when we get into the calculation, what we should master is the equation talking about particle and volume at RTP. If it is talking about particle and volume at RTP, then you connect this particle and this volume. Please be careful here. If the question, as we now get into it, if it is talking about particles and volume at RTP, you have to relate this number with this number. Simple. In chemistry calculation, you don't jump from unknown. You must have a basic fact, and these are the facts I'm giving you now. So it depends on the units where the question is coming from. Don't fear, chemistry calculation is easy, but the problem is that you must understand it, and you must have the knowledge of the theory that guides it before you solve. Which means you can move from particle to volume at RTP, then particle to volume at STP, which means 6.02 times 10 to the power 23 particles of any gas will have this volume. And this volume means 1 mole. It means that 1 mole of any gas will have this particle, and by volume will have this. Then whatever this particle of this weighs, whatever the particle of this gas weighs at STP should be the molar mass of that gas. So if the question is in mass, like they tell you, what mass of carbon 4 oxide will occupy a volume of 11.2 dm cube? What mass of carbon 4 oxide? Let's assume they have that question. What mass of CO2 will occupy 11.2 dm cube at STP? Very simple. My dear, I'll still give you the steps on how to tackle them, but this is one of the necessary steps. Watch this. They said mass, and this mass is the gram. That's the molar mass. That's the only relation that talks about mass. This one now talks about dm cube. Look at their unit. So this is the one bearing gram, and this is the one bearing dm cube as far as STP is concerned. Which means you relate molar mass with what? 22.4 dm cube. But with regard to the compound or the element in question, this is CO2. They will give us in brackets that carbon is 12, oxygen is 16. Very simple. Then you can find the molar mass of carbon 4 oxide. By doing so, the molar mass, that's this mass. Why am I finding the molar mass? Because they talked about mass, and I'm relating this and this. Because this dm cube, this is gram. I will go with this and STP. So what will I have? It should be 12 plus 32, of course. 16 times this 32 will have 44 grams. That's the molar mass. So I will now write that 44 grams of this particular thing will occupy what volume? 22.4 dm cube. This is already known fact because they say what mass. You must understand the unit. They are comparing mass and dm cube. That's mass and volume. Therefore, which one are they asking you for? They said what mass. You come to mass and write x. Then you go there that they gave you this volume, and now give us the exact volume, 11.2 dm what cube. So in this case, you may now do your calculation by crossover, but there are things you have to know without even wasting time. If 22.4 dm cube gave you 44, 11.2 is half of 22.4. 11.2 will still give you half of 44, which is 22. But if you don't understand it, you can still do your normal cross multiply, and we have 22.4x is equal to 44 by 11.2. Across the calculator.
44 by 11.2 gives 492.8.
492.8 divided by 22.4. So our x is now what?
22.
Is exactly 22. 22 what? Some may be confused. It should be gram because this is where the tail is. So this is just the short form of calculating. Let's assume the question says, how many molecules of CO2 are present? Molecule. Please, molecule represent particle. When we say particle, we talk about molecules, ions, or atoms. Assuming the question now is, how many molecules of CO2 will occupy? This time around, you are now going to relate this number and this number because they are talking about molecule versus volume. Clear?
Yes.
Let's assume now the question is reconstructed. They say at RTP now, you are no longer going to use STP. You are no longer going to use this value. Rather, you now use 24. If they change this STP to RTP, you now just replace here with what? 24 dm cube. So you should know first the units that the questions carry. What are the possible units, class? Let's take it that way. This is gram is equal to mole, and mole is also equal to what? Gram. And this is mole equal to dm cube. They may put this thing in cm cube. Just look at volume. This is mass in gram. Volume in dm cube or cm cube. Then this is particle. The major units for particle is 6.02 times 10 raised to the power 23. Then from mole you can go to quantity of electricity for Faraday. So which means if they ask you what is the quantity of electricity required to discharge 0.5 moles of electron, you will now write 1 mole. They say what quantity of electricity? Quantity, that's this. You will discharge 0.5 mole. That's quantity and mole. You relate 1 and 96.5. because what is here is 1. So if the equation is saying how many atoms are present in 6 grams? How many atoms are present? Watch it now. How many atoms are present in 6 grams of, let's say, magnesium itself? In brackets, they will tell you that magnesium is 24. Simple. They are talking about atoms first. You mark it. So when atom appears, you must remember this particle, which is what? 6.02 times 10 raised to the power 23. Then this is mass. So you are working from this to this, but our connecting thing is what? Mole. So you are now working from 6.02 times 10 raised to the power 23 to what? Mass. Mass of what? They call an element, magnesium. Which means you relate the molar mass of magnesium to this particle. And what's the molar mass of magnesium? 24. That is what is in brackets. So where will you start solving? Just write 24 grams will give you what? 6.02 times 10 raised to the power 23. Why? Because the equation is a particle and in mass. There is no other way to memorize except to understand the nitty-gritties, the steps that must be taken. So mole connects everything. If the equation is in mole, you use 1 already and work for that mole. Okay, let's now highlight another rule. If you master this, fortunately I will clean up this. So let me now give you like the theoretical steps you must take during the calculations of stoichiometry. That's calculations involving mole that determines mass and volume. First, simply, you have to write the chemical equation and balance it. Write the chemical what? Equation and balance it. Then, number 2, bring down the stoichiometry. This is for you that have not yet mastered it. You can follow this step gradually. Bring down the mole ratios. Bring down the mole ratios of the reactants and the products. Then, third step is when you have brought down the mole ratios, you go back to what I taught you. From the equation, find 2 species that are related. Find the 2 what? Species that are related. There must be 2 species that are related. It may be 2 products or 2 reactants being related. How do you know the species being related, please? First, under this particular point, you can start going first by the unit given and the unit being looking for. Simple. Given and calculated for. Say given and calculated for. So the one given and the one you are calculating for must be the relating species. When we go into the examples, you understand what I mean. Let's take this question now so that you understand what I mean. Assuming the first equation I wrote was on a calcium carbonate reacting with a HCl. Maybe the question is, calculate the volume. They say what volume of CO2 is produced at STP when, let's make it simple, when 50 grams of limestone reacts completely with excess dilute HCl. So in this case, this is the question you are faced with on your own. First, you follow the rule. Write the chemical equation and balance it. So when you write the equation, how will you write the equation? Find out the reactants and the products. Watch it. They say limestone reacts. So you first of all pick this. This is our first reactant. Reacts completely with dilute HCl. Then if you don't know that limestone is calcium carbonate 4, you have to hire a private teacher to do that for you. Now, What do we have? Our limestone is calcium trioxocarbonate, for some call it calcotril, plus HCl. Then you get your CaCl2 plus H2O plus CO2. Then we have written this before. You put 2 here. You have settled step 1. So, what does it mean? You need to learn how to balance equations. I'll still help you with that, but on a separate topic, not on this one. So now, the second step is bring down the what? Mole ratios of the reactants and the product, which is 1:2:1:1:1. Then we have how many species here? 1, 2, 3, 4, 5 species. Then the third step says, find out the 2 species that are related. Out of these 5 species, only 2 must be related. They can't relate more than 2 in chemistry. What they will relate is none of your business. They may even relate this and this, this and this, this and this, any one they like. 1 product, 1 reactant, 2 products, even 2 reactants can be related. How will you know that? You go back to the question. The one given and the one being calculated for. The one what? Given and the one being calculated for. Now they said, what volume of CO2? So we have seen that CO2 is involved. Yes. They have mentioned CO2 is one of the related species. You go there and mark it, circle it. Then, volume of produced at when they give us something. This is calculated for and this is given. Yes. So 50 grams of limestone was the one given. So which means the one calculated for and the one being given is what is related. So we are relating CO2 and limestone. You come here and circle it out. So you have discovered the 2 species being related. Then what next will you do? Bring out their what? Mole ratio. As we have circled it so that I don't make mistake. Out of these things we have written, we are only going to work with
calcium carbonate.
We are only going to work with calcium carbonate and what? CO2. With respect to their moles, we have 1 mole. Here we also have what? 1 mole. Then this 4th step is find the units. 4th step is finding the what? Find the units for the related species. Find the units for the what? 2 related species. Unit is, are they looking for it in gram? We have seen this. This mole we got is from this, so 1 is to 1. Assuming we used HCl, we are going to use 2. So this 1 is not always the rule. It depends on how the equation is and the related species. So this 1 is composed. You must write it out first because of this equation. Then you go back and check whether the question is in mole. If this calcium carbonate, that is the unit, find the unit. Look up, they gave it to us in gram. So which means we are going to convert this mole to gram. Simple. We are going to convert this 1 mole of calcium carbonate to gram. Then when you come to CO2, are they looking for, they said volume at STP. So in bracket for this question, they will still give you such information like calcium is 40, carbon is 12, oxygen is 16, then gas molar volume at STP is 22.4 bm3. This information will be provided for you. Then, having provided this, you now see that, please, that these things in brackets for Nigerian students are always a mind opener. They always tell you what you're supposed to do. But some British exam, they don't give it. You're supposed to know it by yourself. Rather, they may go behind your book and give you periodic table. So it's not left for you to go and find what calcium is in the periodic table. But for local exam like in Nigeria, they often give this in brackets, which makes it easy. You always know that you are going to use one of those things given in the bracket. So when they give us this in brackets, you have to now convert this mole to what? Volume. Remember what we said? 1 mole of CaCO3 will give you 1 mole of CO2. Then from the question, which unit guides them? This one is given in grams, which means we will convert this thing to gram. Then this one is given in volume, and the unit for measuring volume is dm3. We are going to convert this mole here to volume. So first, convert to what? Volume. This one converts to mass in gram. Then go back to what we say. Remember that 1 mole of any substance at any point is the molar mass. This is 1 here. You simply find this. becomes now, calcium is
40.
40 plus
12.
12 plus 16 times 3. So what do you have here? 40 plus 12 plus 48. Once you memorize that this is 100, of course, that makes you a serious chemistry student. Even if you don't understand, you can do horizontal addition. 0 plus 2 is 2. 2 plus 8 is 10. You write 0, carry 1. This is 5. 6 plus 4. 5 plus 1, 6 plus 4, which is 10. So we have 100 grams. 100 grams multiplied by 1 is still 100. Which means if 2 is here, I will multiply by 2. But I'm not going to multiply by 2 because 1 is here. And how did I get my 1 here? From this equation. I did not just put the 1 there. So what we have here, we now have 100 grams of CaCO3 will give me what? At STP, remember the basics I gave you in the beginning. At STP, 1 mole of any gas will occupy what? 22.4 dm3. Class, assuming there is 3 here, what does it mean? You now just write 3 times 22.4 dm3. But this 22.4 is here because there is only 1 here. So I have just, this and this is the same thing, but I've just converted it to the units given. Then the next step is, you add the next step, that's 5th step. Write x under the species being calculated for. Write what? X under the
Species.
Write x under the species being calculated for. So the one they ask you what is, find out. You must not start from the beginning. They may even bring it at the end. After making statement, they say calculate. So from here, you will put x here because they say what volume. Then when you put x, you can add the value they gave us for calcium carbonate. They gave us 50 grams. So with this, you can cross multiply. Our answer should be exactly 11.2. But let's solve. It's very simple. If 100 was eventually reduced to 50, this one will also be reduced to half. Because this is 100 giving us 22.4. 50 will still give us half of 22.4, which is 11.2. But if you don't get it, let's do the normal calculation. 100x equal to 50 times 22.4. What do we have?
1,120.
1,120. Okay, 100x is equal to 1,120. X alone is 1120 divided by 100.
11.2.
So we have 0, then move back, give you 11.2 dm3, and you have your answer. Okay, so let's solve examples from the exam body from WAEC and JAM, IGCSE. So I hope you get the questions there. So come with the questions. Look at our calculation very well. Have you gotten anyone?
Yes.
Okay. I will be writing them. I will just get the basic facts.
The question is from WAEC 2001, question number 45.
Okay.
Calculate the mass of zinc sulfate.
Calculate the mass of zinc sulfate.
Produced when excess of zinc carbonate
Excess of zinc carbonate
is added to 50 cm3
is added to 50 cm3
of zinc carbonate.
50 cm3 of
Zinc carbonate.
when what excess?
Okay, it's added to 50 cm3 of 4 mole per dm3.
4
mole per dm3.
Okay. 4 mole per dm3.
H2SO4.
H2SO4.
The equation for the reaction is
Okay, they even gave us the equation, yes?
zinc carbonate plus
Zinc carbonate plus
H2SO4,
H2SO4, of course, to give you
giving zinc sulfate plus CO2
plus
plus water.
CO2 plus water.
In brackets, we have zinc sulfate equals 161 gram per mole.
Okay, zinc sulfate is 161 gram. That's the molar mass. Okay. Then, from the rules on the board, remember your mole relation. Mole connects everything. Even if they have solved step 1 for us, you are lucky, and that's why for you. But most of the times, JAM will not do that for you. So in this situation, step 1 is gone, that's this. Then you go to step what? 2, which is bring down the mole ratio. I think it's 1 throughout. That's 1 is to 1, is to 1, is to 1, is to 1. Because the equation is balanced. So then, what are the species related? Try, you that is watching, try and check if you can find that now. Let me just give you a few minutes. From the question, try to check if you can find the species related. Calculate the mass of zinc sulfate produced when excess of zinc carbonate is added to 50 cm³ of this. Remember, find the 2 units related. How do you find it? The one being calculated for and the one that is being given. So which one did they tell us to calculate from? Let's check if you got it. They said zinc sulfate. So this is our first man. Did they give us any value? Go to that value they gave. They say 50 cm³ of 0.4 mole. They gave us this. So we are relating H2SO4 and zinc sulfate. What next? You bring down their moles. What mole? 1 mole of what? H2SO4 will also give us what? 1 mole of zinc sulfate. Don't be fooled by saying it always end in 1, 1. Just because the equation we are using is ending in 1. You may use the one that will have 3. You also be careful to use it. Then the next step is find the units. Is it not? Yes. They say calculate. This one, are we looking for it either in mass or mole?
The mass in gram.
In gram. And that's what they gave us in bracket. So we have to write now here that if you finish calculating all this, the molar mass will be automatically 161 gram. So you have to convert this 1 mole to 161 gram. If there is 2 here, you say 2 times 161, but unfortunately it's 1. Then here, did they give us anything? Yes, they should. Check from the question. Okay, it was given in mole. I think I love this. This was, the unit is in mole, which means we will leave this 1. We are not going to convert again here because this unit is in mole, and whatever that is here is in mole. So we just simply write 1 mole will also give us what? 161. Next step, write X under the one being calculated for. Which one? They say mass of zinc sulfate. So we'll write X here. Then what was given here? They said 50 cm³. Please be careful with this place. 50 cm³ of 4.0 mole. So avoid even longer. If you ever have this type, to get the real mole to be used, because moles should be in, this thing shows that 1000 contains 4.0, while they are not asking you have to find out the one that is in 50. So cut it short, just say volume by mole all over 1000. Simple. Volume given volume. Volume given times what? Mole given all over 1000. What is the volume given? 50. What is the mole given? 4. All over 1000. What do we have? 50 by 4 should be 200 over 1000. Please watch. If you have 200 over 1000, don't waste time pressing calculator. Just cancel, 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 so that you have your 2 over 10. Then anytime you have 2 over 10, you write these 2 down. Move the point here. Bam. It becomes 0.2. So 2 over 10 should be what? 0.2. Even if you want to understand more on this, anytime they say 1 over 10, it should be 0.1. So 2 over 10 will also be the same thing as what? 0.2. So even if you divide to the lowest term, what will you have? 1 over 5. Is it not? And 1 over 5 is the same thing as 0.2. Because if 1 over 10 is 0.1, 1 over 5 will be 0.2. Then 1 over 2.5 should be 0.4. Some are not understanding, but if you follow the pattern. Okay, what do we have here? We have 0.2 mole. It means that 0.2 moles of what? H2SO4 is what is provided. So what will we put here? We will put 0.2. How do we get it? Volume given times mole given all over 1000. That is just to make it easy for you. But if you must understand how, you write, please, this 4 mole per dm³ means that is 4 moles in 1000. 1 dm³ is equal to 1000. 1 dm³ is equal to 1000 cm³. So what does it mean? It shows that 1000 contains what? 4. 50 will contain what? Automatically 50 will contain 4 over 1000 times 50 over 1. So what do we have here? So it is still boiling down. So give you 1 over what? Okay, so we have 20 over 100, right? That's 4 by 5. So we'll still give you 0.2. That's how we got this. But this is just the simple way. If you see this type, they give you volume with concentration in BMP. We just say volume given times mole given over 1000. Simple. Then we have not gotten our answer. This is our x, of course. Then what happens? This one is very simple also, but let's keep solving so that you understand. What will you have here? We have that x is equal to, that's cross multiply 1 by, that's 1 by x will give you x equal to what? 161 times 0.2. You don't even need calculator here. If this type of thing happens, count the figures after the point. These are the cheats you need. That's how many numbers are after the point? 1. Only one number. So you write out 161. There are only one character here. You now move this point. Remember there is point, so you move it 1 behind. Let's assume there is 0.02. 0.02. You are going to move this point 2 times. That's 1, 2. You put it here. But here we have only one character. So we move it what? 1. This movement has cancelled this point. So when we move it, this point is off. So what do we have now? We have 16.1 times 2, because this 2 remains, which is equal to 32.2 what? 32.2 grams. So that is our answer.
Okay, this one is from the same year. That's the theory part of that year.
Okay.
Question 1B, 3. Is it a chip?
A chip
Used in a microcomputer.
Yes.
Contains 5.72 times 10 power.
Contains what?
5.72
times 10
power minus 3 grams.
Minus 3
gram of silicon.
Gram of
silicon.
Silicon.
Calculate the number of silicon atoms.
Calculate the number of silicon atoms
in the chip. Crystal.
Okay.
In brackets.
Silicon
atoms in the chip.
Atoms in the chips. Okay. They said in brackets.
In bracket, silicon equals 28.
Okay.
Semicolon.
Avogadro
constant. Equals 6.02
times
10 power 23 per mole.
You will see the complete question on the screen. They said a microchip contains 5.72 times 10 power minus 3 grams of silicon. If it contains this, if it has this gram, then how many atoms? You go back to what I taught you in the beginning. We have gram now versus particles. Grams versus particles. So which means particles for 1 mole is equal to 6.02 times 10 to the power 23. Which means now that they are talking about mass and particle. Mass and particle. Which means we now go for silicon. 1 mole of silicon will weigh 28 grams. So what does it mean? We now write 28 grams of silicon because they said atoms. We relate it with what? We contain 6.02 times 10 to the power 23 was atoms of silicon. It means that when you go and pick this number of silicon as an atom, 1, 2, 3 to 6.02 times 10 to the power 23, put it in a weighing balance, it will give you 28 grams, and that's what we call molar mass.
Times 10
10 to the power what? 20 what class? Atoms. Because that's what they gave us. Our final. Then we have tried for this particular stoichiometry for today. To wrap it up, remember you need to use the comment box if you are confused. There are many other examples. You can also send your questions in the comment box or choose a topic. In any way you're confused, we'll be there. We will give you other class works. Try your ability here. Sa Majesty Easy World Science Channel. Remain the easy world of science. We make things easy for you, even in practicals, in biology, chemistry, and physics. So share this video, please. Like and comment. Tell your friends that you have seen the way out. I'm very sure that if you go through these lectures again, you won't find stoichiometry so hard as you have found it before. God bless you.